In this lesson, mo problems. Oh, we don't want mo problems. There we go. How about some mole problems? We'll see how to do mole problems here. Working with the moles not too bad if you can do your algebra and if you know what everything means. So everything in this section will boil down to using one of these two formulas or both. There was a different video introducing these, so you can watch that if you don't know what they are. Mass equals moles times molar mass, and big N, or number of individual items, is equal to moles times Avogadro's number, 6.02 times 10 to the 23rd. So here's an example of something that you might be asked to do. How many moles of calcium phosphate are there in 25 grams? So we need to identify, first of all, what are we being asked? We're being asked for how many moles. So we're being asked to find moles. So we can use either formula now. So the question is, what do we have? Well, we have grams. They give us grams, so we know grams. And they also, we can look here and we can see that we can actually do this if we know W. Well, we don't know W. It doesn't say how many grams there are per mole, but it does tell us that it's calcium phosphate. So we need to write a formula. So calcium is this type 1, so we're going to do the charges thing. Phosphate is -3, calcium is +2, so we need 3 phosphates and, 3 calciums and 2 phosphates. So we have 3 calciums. We're going to doing all this to find W here. 3 times 40.1 is 120.3. 2 phosphoruses is 2 times 31 is 62.0, and 4 times 2 is 8. Oxygens is the molar mass is 16.0. These numbers here are coming off the periodic table for calcium, for oxygen, and for phosphorus. And so then I just multiply by how many there are. So I have 8 times 16 is, what's 128? And I'm going to go 1 decimal place on each of these. So I have 120.3, I have 62.0, and I have 128. If I add those up, I get 310.3 grams per mole, and all of that is W. That goes in here. So, as it turns out, I do not need this formula. I can do everything using the mass formula in this case. So G is given in the problem as 25.0, and that equals N, which is what we're trying to find, times W, which we've just calculated, is 310.3 grams per mole. So we're going to take 25 grams divided by 310 grams per mole, and that will give us moles. So let me grab my calculator here real quick. And we do in fact get an answer of 0.080567, which I will round to 6 to keep 3 significant digits. The unit is moles. It is not N. N equals blah blah blah, but you would not say blah 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 N. So N equals 0.0806 moles. So that would be how you would do a problem like that. Well, what about this? How many molecules are there in 25 moles of steam? So let's identify what we're given. We're given 25 moles, so we know that. Obviously, we know Avogadro's number. We always know that that's a constant. We know that it's steam. Steam is water. We can find the molar mass of water, so we can find just about anything we want here. We have all sorts of information. But we need to see, what is it asking us to find? It's asking us to find molecules. That is big N. That is what we're trying to find. So we're going to use the second formula, and we're simply going to just plug and chug 25.0 times A, which is Avogadro's number. And so that gives us an answer of 1.5. Let's see, 3 sig figs, 1.51, I guess it would be, times 10 to the 25th molecules of water. Steam is, of course, water. And that would be how we would do that problem. The next example we have here would ask how many atoms are there in... Well, I wasn't thinking that through very well. That is the same, basically the same problem we just did. We'll skip over that one. let's go to this one. What would 5.3 times 10 to the 25th ammonia molecules weigh? So, once again, we look through the problem to see what we either know and what we want to know. We know this. Actually, I guess I've been using red for what I don't remember what color I've been using. I'll just go ahead and use red for the thing we know. So we know that is how many molecules we have, so we know that information. Ammonia is something you maybe don't know what it is, but you could always look it up, and you could find that its formula is NH3. That means you know W. We always know Avogadro's number, and so the question then is asking us to find what it would weigh. Well, what it would weigh is the mass. There you go. You can tell that we need to use the top formula, which is easy enough, except that we do not have the moles. Fortunately, if we look down at the bottom, we do have enough information that we can find the moles. We're going to take so we're going to start with this formula, and then take your answer and finish using that first formula, the top formula. So let's do that. So what is capital N? It is the molecules. It's 5.3 times 10 to the 25th. And that equals moles times Avogadro's number. And this is the number that we're going to then divide both sides by Avogadro's number to get 5.3 times 10 to the 25th divided by Avogadro's number is about 88.0. If you get something other than that, which a lot of you will, it's because you didn't use your calculator correctly. I'd refer you back to the calculations, how to use your calculator video that we made before. So that is moles. We just found moles, so we can take that and plug it in up here. And so if we do that, G equals N times W, we would have G equals N, which we just found to be 88. I'm using this formula here. 88.0 is the moles times W for ammonia. Oh, we didn't calculate that yet, did we? Well, we have one nitrogen. Nitrogen is 14.0 off the table. And we have 3 hydrogens, which are 1.0. So 14 plus 3 is 17.0. So the answer is going to be 88.0 times 17.0, which is, to 3 sig figs, 1,500 grams. And there we go. So we've done one where we found grams, we've done one where we found molecules, we've done one where we found moles given weight, we've done moles. I think that's pretty much covers it. If you like, you can go back and do this other example. And oh, I see, that example is a little different. It's 2 steps. So let's go ahead and run through this real quick, then we'll be done. We have, this time we want the number of atoms. It's not the same problem. It's not the same problem because we're given different information. I was thinking through this quite clearly when I made it than I wasn't when I was making the video. That's how I roll. We know Avogadro's number always. It's zinc. I don't know if you've noticed what I'm doing. Every time I get a problem, I identify what I know and what I want to know. And that helps me figure out what formula I need to use. I know it's zinc, therefore I know what W is. I know what grams are. That's given in the problem right here. And so then obviously the bottom formula is what we want. However, a lot like what we just did, we do not have the moles, so we can't use that yet. So we're going to have to use 2 steps. We're going to use this first, and then this. Oh wait, take that back. We don't have enough to do the bottom one. We're going to use this one first, and then use that one, because we can solve for little n using that top one right now. So we plug in what we know. We know G is 459. We know N is what we're trying to find, and zinc, I believe if you look zinc up off the periodic table to 1 decimal place, it's 65.4 grams per mole. And then we divide both sides by 65.4 to get moles. So 459 grams divided by 65.4 grams per mole is 7.02 to 3 sig figs moles, which we can now plug in Now we know this, so we know this, so we can now plug it in up here to get the number of atoms, and that's going to be moles times Avogadro's number, so we can take that times 6.02 times 10 to the 23rd, and boom, 3 sig figs, 4.23 times 10 to the 23rd. And by the way, on my calculator, I did not round this, although I did on the video, so that if you don't get exactly this, this is the better answer, because I shouldn't have rounded here because I shouldn't have rounded here because I wasn't done. That should be 0.15 or something like that. So this is the best answer, and the unit is atoms. We found that many atoms, and that is how you would do those kinds of mole problems.